Hi guys and girls on YouTube, welcome to my channel, welcome to this quick video. So I've got this Sony KDL-40WE663. Now this is a pretty common fault on these. It comes on with a Sony logo on the front, stays on for 5 seconds, then it goes off, it reboots. It does that a couple of times and then the LED on the front flashes 6 times, which is usually caused by backlight failure. Now this is actually quite a common fault. In fact, I've had it that many times now that when this came in, I automatically changed the backlight strips. But guess what? It didn't work. It's still got exactly the same fault on. So with 2 new LED bars not curing the fault, we turn attention to this little board here. Now there's not actually a great deal on here for the LED driver. That FET there, that's the on and off switch. All this in the bottom here, that's the sound output stage. The LED driver is only this little tiny bit at the top. Now there's quite a few protection circuits built into that IC, so the easiest thing to do is to override the protection, and that will give us more time to look for what the problem is. So if we take a quick look at the data sheet for the LED driver, the BD9423EFV, you'll see here that the fail output, that's an open collector output. When that FET is activated, it'll pull that pin down to ground. So what we need to do, that's pin 2 of the IC, we need to keep that high to disable the protection circuit, and then we can look for what the problem is. Now I don't actually like cutting the printed circuit board, so what I've done is I've disabled pin 2 from the main board by putting a little bit of sellotape under one of these pins, and I'm going to try the set again now and see what happens this time. Right, so with the protection circuit now disabled, I turn the set on. It comes on for about 10-15 seconds, then the screen goes blank, the backlight goes off. If you leave it, after a short time the backlight comes back on again, and then after a short time it goes off again. Now what I've noticed here is this IC, it gets so hot you cannot touch it. So clearly there's a problem here somewhere, but I've just put a digital thermometer on the top. I'm just going to plug it in and show you this. Right, so here we go, just flick it on at the mains there. That's the IC temperature at the moment. The set's just come on, you can see there. Now look at the temperature rising. So in just a matter of, like, I don't know, 10-15 seconds, that IC temperature has nearly reached 100 degrees C. In fact it has, it's gone over 100 now. Let's turn the telly off. So definitely that IC is overheating. Now the sensible thing here would be to just put a brand new board in. These are only about £12 for a brand new one, but we don't always do sensible here, and sometimes when you do sensible you don't learn anything anyway. So I've had a look at the data sheet, and the 6 resistors there, I'll show you them on the data sheet in a minute. They are the earth return paths for the LEDs. Now the number 6 one, which is about pin 28 or something on the IC, that doesn't have any voltage on, so there's no LED current flowing to earth through there. The LED current must be flowing to earth internally in the chip, which means it's not current limited. So I think the best thing to do is to just change that chip now and see what happens. But let's just have a quick look at the data sheet. Right, so that's the data sheet there. You've got your, well, there's actually 6 LED chains. So the current goes in there, it goes through that FET, and then it comes out of another pin and it flows to earth through that resistor. Well, on one pin we don't have any voltage on there, so presuming the LED current's flowing through a short circuit somewhere in the IC. So I'm just going to whip a new one in now and we'll see what happens. Right, so the first thing you need to do before you change that IC is make a note on the board which is pin 1, because there's no actual identification marks on the board. So pin 1 is on this side here. Right, so that's as marker then. Let's just get the chip out now. Right, so that's the chip actually desoldered. Now, because it's such a small chip, and if you look, there's components very close to the chip that we don't want to knock any off. I've used a pair of Ideal Tech AASA tweezers just to hold a couple of pins of the IC, because these are so fine that they go between the pins. I've just held this corner there and then heated it up with hot air and lifted it off. So the chip's already been desoldered, and if you can see, these are so fine that we can just hold one pin to lift it. So that's it. There is of course heat sinking on the back, so we just need to pop that a new one back onto there with hot air now, and then let's see what happens. Right, so I fitted a new chip in. If you get in without casting a shadow, there it is, there's the new chip. And guess what, the fault is exactly like it was before. The new chip just heats up until the backlight switches off, and then as the chip cools, the backlight switches on again. Let me just see if I can show you that. I've got the TV face down, but you can see the backlight's lit up through these holes. See, it's blinking on and off. When the chip heats up, the backlight goes off, and as it cools down slightly, it comes on again. So we're back to square one. The same problem. So what now? Because there's virtually, well, there's only a handful of parts actually on there. Right, so time to do some testing with one of the old backlight strips. Now, I don't know if you're familiar with these, but all these LEDs on here, they're not all in series. These 3 separate strings, so a third of it will light up, and then another third, and another third, and that's why there's so many wires going into the screen itself. But what I've actually found is the pin with no voltage on, that is actually driving one of the LED strings. So I've no idea why the voltage is different to the other 5 strings, but when I clip this on, which I'll show you in a second because I've got the camera on a tripod now, it actually drives the LED strip, so I really don't know what's going on there. Right, so here we go. Hopefully you can see that. I'll just turn the telly on, and then if I take this and touch it onto there, that's one output. That's 2 outputs. That's the third. That's the 4th, 5th, and 6th. Just unplug that. So all the outputs from that chip are actually working. So why on earth is the chip overheating? I've got to stop the camera now and think about this. Right, so I've decided what I'm going to do. I'm going to measure the current running through one LED strip. So if we just try the one that I thought was faulty, it's lit up now, and we're actually running an LED current of, well, just over 57 milliamps. In fact, I've tried all 6 of the LED string outputs, and they're all running 57 milliamps. So 57 milliamp times 6 strings, that equals total consumption of 342 milliamps, which seems pretty low to me, but just let's have a look at what the data sheet says. Right, so the data sheet says the maximum current per string is 400 milliamps. And we're only running 57 milliamps. In fact, we've got less than 400 milliamps for a string of 6. So what on earth is going on? Why is this IC overheating when the backlight comes on? I have no idea. Right, so I've actually got this connected to my backlight tester now. You can see the string runs 1, 2, 3, 4, 5, 6, 7, 8. So there's 3 banks of 8, and if we have a look at that, we're running a forward voltage of 52.3 volts. Right, so let's do another quick calculation. 52.3 divided by 8 LEDs, that gives a forward voltage of each LED of 6.53 volts. Well, that doesn't seem out of place, because I don't know if you've noticed, but there's actually 2 LED elements in these. There's one there and one there. So you can assume about 3.2 volts for each LED. So that'd be about right. So there's no abnormality on the LED strip either. So I really do not know where to go next. I'm going to sit down, have a look at the data sheet, and then we'll come back in a minute. Right, so I've checked all these trip conditions. We've got over current protection, over voltage protection, under voltage lockout. All them are correct. So none of them are actually tripping the fail output, but I've still got an abnormality on one of these LED string outputs. This is what it's down to. This is what I can't get my head round. These are the LED string outputs. I've got no voltage on pin 11, but I've got 21 volt about on all the others, but nothing on pin 11. So if we have a look here, pin 11, that comes through the LED chain. Now the only possible thing that could cause no voltage there would be either that Zener diode or that capacitor short circuit, but in that case the current's not flowing through here and coming out of these resistors here, so you would expect this chain to be drawing far more current if one of them was faulty than the other 5 stringers, but it's not. I just cannot see what the problem is. I mean, it seems very, very simple, but I'm going to take the board out and just see if I can locate these parts. Bearing in mind though, this is only the data sheet for this chip, so these might not even be fitted in mine. Right, so pin 11, in fact it is like it's just shown on the data sheet. It goes to 2 components there, and if you look, we've got 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we do have a capacitor, and well, that actually looks like a resistor, but it's shown on the circuit as a diode, but it might be some sort of transient suppressor device. Let's just see if we can zoom in. Yeah, we can zoom in there. So I've actually measured, this is where we have no voltage, this is where we have a voltage. These 2 pins here, that one and that one, I suppose the sensible thing to do would be to take that and that out and just see what happens, but there's no measurable leakage any different across that pair than there is across that pair. Right, well that's the capacitor out, and also the bit that's shown on the diagram as a Zener diode, which I think is probably a transient suppressor diode, went across there. That's out. There's the capacitor there, and you can see how small these parts are. That's the other bit there. I've taken them out, and it's made absolutely no difference whatsoever. Now the only other possibility I can think of is one of these wires is actually chaffed somewhere inside, and it's shorting onto the case. But I can't measure any resistance between any of these pins and the ground, so I really do not know. I think we've got only one option now, is just to order up a brand new board and see what happens. Right, well it looks like it's my lucky day today. I'm just getting ready to order this board today. I'm just putting an order together for Aswo, and guess what? Somebody has brought in another identical set with a completely different fault on. So we can actually borrow the board out of this one and try it in that one and see what happens first. Right, well that was a stroke of luck getting another set in, and it saved me even more money because I've put the board in that I thought was faulty with the new IC in. I've put the board back into this set and it works absolutely fine, and I've put the board out of that into this set and the chip is once again overheating. So there's a problem with either the new set of LEDs we've put in, or there's a leak somewhere between one of these wires and the case. I can't detect any leak with a multimeter, but there's certainly something wrong with the LEDs we've put in. Right, we're getting deeper and deeper into this than ever. I've done some tests and it appears that one of the strings is open circuit, which I find a bit strange because I've tested this before, put the screen back in and they all lit up okay, but my tests indicate that the number one string, which had the 0 voltage on, that is open circuit. So what I'm going to do, just as a quick test, I've still got the wires connected to here, I'm going to just solder these onto the board and we'll try again. Right, the more I look at this, the more confused I'm getting. So if I tap onto there, we've got an extra external string lit up, but the IC is still overheating, even though a string appears to be open circuit in the telly. The more I look at this set, the more I'm getting confused. Right, so as a last resort and with great difficulty, I managed to plug this screen into that board, and it's running now, it's staying on, the IC is cool. So there is absolutely something wrong with them LEDs I've fitted, which is very strange because this is the same fault it had in the first place, or it would have been the same fault until I blanked out the trip part. But anyway, you can see now it's staying on. Absolutely something wrong with the LEDs. I don't know what, but I'm going to just have to order another set and see where we go from there. Right, so here we go, round two. Another set of new backlights have just arrived. Right, so that's the screen out again. I'm going to turn it on again and just have a look. It won't stay on for long because without the T-con board, with the T-con board disconnected, it'll switch off after a few seconds. So here we go, plug it in. When I can find the on and off button. Yeah, up there. There we go, should be coming on. Yeah, and you can see there's a row of LEDs at this side not lit. So there is some LEDs not lit. Right, let's take a look. And that's the answer there. I can see the problem. The end LED is actually cracked. There you go. So I don't know what on earth's happened there, because it was alright when I fitted it. I tried it, all the LEDs were lit. So something must have damaged that, but I can't for the life of me see what. But anyway, let's fit another strip in. Now they do come in a set of two of these, but as the other one's brand new, there's no point putting both of these new ones in. We'll just put one in. Right, I can see exactly what's happened. That little plastic spacer there where the back diffuser sits on, if we look on that there, I must have lost it, and the diffuser's actually sat on top of the LED and cracked it. So we've got a better view there. You see the diffuser sits on there and it keeps the LEDs away from it, from the heat. So I don't know what we're going to put in there in its place. Right, so that's it, all back together. I could not find that piece of plastic that's disappeared. I thought I put it back in, but obviously I hadn't. so I've had to make one out of just a scrap piece of plastic, but there you can see it's all up and running now. I'll just turn this back onto Sky. So I'm just going to run this for a bit. Right, so that's all tested and ready. There's one final job to do, very important, mustn't forget this, is take off the piece of tape that I put under here to disable the trip. You can just see it there. It's just a piece of sellotape to cover up one pin so we can keep the set on. So yeah, that's the last thing to do, and then we're all up and running. So there we go, all waiting for the customers to collect. So what lesson have we learnt from this TV? Well, the most obvious one is don't lose any parts out of the screen when you come to reassemble it or disassemble it. But apart from that, we've also learned that if there's a whole string of LEDs open circuit, then the driver IC overheats, and that can be very confusing when you come to fault finding. But anyway, that's it, the set's done. We've learnt the lesson now, on to the next job. Alright guys and girls, many thanks for watching my channel. I'll catch you in the next video. Goodbye.